speaker, Anne-Marie Cook. She started her career with the US EPA in the 90s and until recently served as a senior engineer and microplastics expert for EPA's regional office in San Francisco, as well as EPA's Office of Research and Development. She recently co-founded Kamilo Inc., a mission-driven corporation dedicated to bringing market-driven solutions to the global plastic waste crisis. She will be discussing microplastics today. Anne-Marie, the floor is yours. I just need to take a moment and share my screen for everyone to be able to see the slides. One moment. Okay. Is everyone able to see the presentation slide? Yes. Okay.
Yes, I see it. Thank you so
Okay,
much.
perfect. Okay, the floor is yours.
Well, thank you so much, Simi, for the introduction and for the invitation to share and discuss with this group my experiences around plastic pollution and microplastic particles. And as you mentioned, I have had a fairly long career with the US Environmental Protection Agency. I started off working in the drinking water and groundwater offices, and then I moved into Superfund, which deals with the largest hazardous waste cleanups in the nation. And around 2009, I started becoming increasingly interested in the problem of plastic pollution. And at that point at EPA, the sort of concept of plastic and its properties for polluting were really confined to the solid waste realm. It was something that EPA had assigned to states, municipalities, landfills, and haulers to sort of monitor, take care of, report back on, but it really wasn't on their radar as something that was a potential threat to human health and the environment. And so when Jared Blumenfeld became our regional administrator and was assigned to our region, and he's now the Secretary of the Environment for the state of California, I went to him, and this was in 2010, and I asked whether I could start a marine debris plastic pollution program for the regional office in San Francisco. And he gave me the go-ahead, he gave me his support, and said, go and do that. And I had no resources, no funding, no direct statutory authority to do that. But I did have a small group of very dedicated people working with me. And together we were able to launch our program in 2010. And shortly, by the end of 2010, it was sort of flourishing within the region, although not yet nationally. And in 2011, in March of 2011, the earthquake, that 9.0 earthquake, hit the Fukushima area of Japan with a huge resulting tsunami that washed a large amount of debris into the ocean. And the state of California and the other states of Hawaii and Washington, Oregon, Alaska, the US Navy, which was stationed in Japan, and other areas turned to EPA in part as one of the many federal agencies responding and helping to respond to that disaster, to ask what they needed to know about marine debris, about the currents that were going to wash up marine debris. The tsunami itself, within a few hours, hit the US. The first area to get hit was Midway Atoll in the northwestern Hawaiian Islands. It was severely impacted. And then Alaska, Washington, Oregon, California, and Mexico were all hit. That was within a few hours. The debris itself took much longer to get over to the West Coast. And we can go to the next slide now, Simi. What happens with debris is it washes into the ocean and it is swirled around by currents in all the oceans. So each of the world's oceans has its own gyre. That's a combination of currents that swirl around. In the northern hemisphere, they swirl around in a clockwise direction, and in the southern hemisphere, it's the reverse. And they carry the debris that exits the continents into the water. They carry it, and it lands on certain land masses as it moves around the water. And so within about 9 months, Alaska was starting to see things wash up from the tsunami, and then Washington, then Oregon, then California, and of course the Northwestern Hawaiian Islands and the main Hawaiian Islands will also hit very hard with debris. And in the course of working on this, people's awareness of the movement of pollution in the ocean increased enormously. We were working with the transatlantic and the Trans-Pacific racing crews, and they were observing large amounts of debris as they were racing from the West Coast to Hawaii each year, trying to avoid the debris, but they were also documenting the debris. There were parts of boats, there were refrigerators, an enormous amount of red light bulbs. So it was a very interesting and sort of sobering realization of how much is in the ocean, how much was moving around the ocean. We all knew this before, but we weren't necessarily aware of it. So this really raised our awareness of the problem of plastic pollution. So we can go to the next slide, Simi. And at this point, there are some recognized realities. I think these are sort of unarguable facts. One of them is that plastic production continues to increase significantly. There is some concern that with the decrease in fossil fuel use for transportation purposes, that the sort of delta between that use and what the producers want the use to be will be then transitioned to plastic. So perhaps plastic is going to be even more increased in use than it was anticipated maybe 10 years ago. The other thing we know is that collection rates are not the same thing as recycling rates. So although a lot of plastic may be collected from municipal and residential collection systems, it is not necessarily all recycled. Some of it is landfilled, and there's no real actual verifiable way at this point to measure what those true recycling numbers are. We do know that plastic pollution causes adverse physiological impacts to wildlife. This has been well documented for decades. The picture here is of an albatross chick at Midway Atoll. The chick has died either from dehydration or starvation. Its parents have brought back plastic, believing that the plastic was food when they were foraging, and fed it to the chicks. And we see tens of thousands of these chicks dying like this every year. So it does have a very large impact physiologically on the ecosystem. And then the thing that we, I think, across the board all agree on, no matter where we come from, is that plastic does not belong in the environment. Next slide. So plastics have some unique characteristics that we don't see with other types of pollutants and contaminants. And one of them is the way that they break down into different types of sizes. So on the left-hand side of the screen here, you see sort of a typical environmental plastic situation. This is a rack line where the tide has washed up plastic into the beach and into the rocks. And as it sits there and weathers in the sun, it breaks up into smaller and smaller and smaller particles. And you can see from the picture next to there, that's a little tiny fragment. It's only 2 millimeters in size. And you can see there's fissures and fractures on the surface of that piece of plastic. And what those fissures and fractures do is that they allow the particle to break into ever more and more smaller sizes. And this is one of the defining characteristics of plastic, are these little fissures. Plastic particles are not inert. They're made with lots of plasticizers and chemicals added into the plastic at the point of manufacture. This makes the plastic have unique properties, so shatterproof, it won't melt in the sun, those kinds of things. And then also plastic has this really interesting property that it acts like a sponge in the water environment, and it will attract legacy contaminants, things like PCBs and mercury that are out in our water bodies in very small quantities. It attracts those to that sort of fatty substance that is plastic, because plastic comes from oil, and it harbors them and concentrates those contaminants on the surface of the plastic. So when creatures eat these pieces of plastic, then there is the concern that those chemicals and plasticizers entrained within and on the surface of the plastic can get out into the body of the organism and impact the organism. Next slide. And one of the very confounding things about this contaminant is its enormous size range. There's no other contaminant that I'm aware of that has this amazing property of size difference. So we can go all the way from the macro size, which are the fishing nets, the derelict fishing nets, for instance, that can weigh 10 tons. And we go all the way down to the nano-sized particles, which is so small that the human's eye cannot find them. And there's very few instruments at this point that can actually work with them. And to give you a sense of the scale from the large to the small is 15 orders of magnitude. That's 15 zeros. So 1,000 has 3 zeros and 1,000,000 has 6. We're talking 15 zeros here. That is an enormous range. And if you look at the diagram on the right side here, it's sort of a blown up version of the micron size, of which many people and many researchers are working with right now. The very large circle there is representative of 70 microns. That's the thickness of a human hair. And then the little tiny, tiny dot there is 2 microns, which is the size of a bacteria. And then we actually go into the nano size. And so what we found with our contaminants in the environment is when they're particle sizers, the smaller the particle size, the more they exist. So we see this with wildfire smoke when we're looking at the particulates from that. In the smallest size range, the number of those smaller particles goes up exponentially. And when we look at lead particles, lead dust, the same thing. The smaller the size particle, the more we find of it. So we expect this to be true for plastic too, that what we're seeing in the micro size range, which is very, very large, is actually going to go up exponentially as we move into the nano size. And it is in pretty much every media that we've ever looked at. We've found microplastics in air, in water, in soil. So it's everywhere. And just to keep that in mind, this is a very, very, very prevalent and widespread pollutant. So next slide. So back to sort of the transformation from starting the marine debris program to where I am today, we'll move into 2013. So we've gone through the tsunami and sort of working with the large debris, and now we're focusing in on the smaller microplastic particles. And what we wanted to do was see exactly what I was talking about earlier. Are those toxic compounds and chemicals within the plastic being transferred to fish? And so we did 2 studies. We did one study in the North Pacific Ocean and one in the South Atlantic Ocean. My colleague, Harry Allen, was instrumental in making this happen while we were at EPA. And we used lanternfish, myctophids. We chose them because they are prevalent in all oceans. They are the largest of all the fish species in number. And they are at the basis of the food chain. So they're not the complete bottom zooplankton level, but they are just a little bit higher than that. And so we figured if we could show that there were plasticizers in fish tissue at that trophic level, then we could be pretty sure that anything that was eating those myctophids was also being exposed to it, to the plasticizers. So we dissected out the stomachs of the fish, and then we analyzed the fish tissue with a lab in Canada that was capable of going down to the levels of detection that we needed and looking at the types of plasticizers that we were asking them to do. And the startling thing was that in every single one of our fish, we found PCBs. And in every single one of our fish, we found 1 or more plasticizers. So BPA, alkaphenol, or PBDE were present in every single fish. We also found that there was a statistically significant correlation between the occurrence of PCBs in our fish. The higher the concentration of PCBs, the more likely we were to be finding alkaphenol. So we saw that there was some sort of, quote, smoking guns here, that there were things to be concerned about for sure. And we continued with our studies on the fish. So the next slide. And then what we did when we got a little more funding was we took those extracted stomachs from our fishes and we started looking in the stomachs for plastic. And we had to develop the method ourselves. We worked with the California Department of Environmental Health, which has an amazing lab looking at air particles, tiny, tiny, tiny particles. And we looked at the fish stomachs to see if they contained plastic. And we found that a significant number of the stomachs did contain plastic particles. And I threw this one into the presentation because it's one of our more fascinating findings. We found a fiber in one of our myctophid stomachs. It took up the entire stomach. And you can see when we blow up that fiber with our scanning electron microscope to about 2,000 times, you can see those fissures that I talked about earlier, even on this fiber. And I think this fiber is probably from a fishing net. No way to know for sure. But those fibers even the tiny fiber had all these fissures that would then, of course, let it break up into smaller and smaller particles, so even more micron size, and then into the nano size. And the way that we positively identified the fiber was using spectroscopy with a spectrograph that can identify what type of compound you're looking at. And it's necessary to do that. The human eye can't discern at the very small scale with any sort of exactness whether something is plastic or not. So I'll go to the next slide. And here's an example of what I'm talking about. So we did our fish studies, and we, in the course of doing all these studies out in the field, we recognized that there was a need, along with many other researchers, for international standards to collect, sample, prepare, and identify plastic in the environment. So to this point, people had sort of been doing an ad hoc version of their research, their own methods in their own labs. And it was really difficult for the labs to really compare results and studies. There was a lot of misinformation coming out, a lot of sort of well-intentioned studies that weren't based on reproducible methods and methodology. And so at EPA, we took our work to the ASTM, and they're an international standards body that is very well recognized. It's a consensus body that's made up of government agencies, industry, NGOs, researchers, and everyone comes together sort of in a collective way to work on things that interest them, and then they can approve methods that are put forward to them. And we decided we'd really start off with an enormous challenge, because there were a lot of, there is still to this day, a lot of concern around wastewater treatment plants and the amount of microfibers and microparticles that are coming from wastewater treatment plants into the environment when they discharge into a water body. And so we said, well, let's just start there. Let's start with wastewater. Take the most difficult media that we can think of, pretty much, and we'll figure out how to work with that. And if we can figure that out, then we can do pretty much anything else. And so we spent close to 3 years developing the method for collection and preparation of wastewater samples. And what we found was that the toilet paper made a very confounding matrix to work with. And you can see here, these are toilet paper fibers. They bear a huge resemblance to the fish fiber that we found. And so what is necessary, without any doubt, is that you have to use some sort of spectroscopy or pyrolysis identification system to know really whether or not you're dealing with plastic. And so after all this work, we were able finally in 2020, and we can go to the next slide now. In 2020, we were able to get from the point of having a very dirty wastewater sample, which is the one on the left, which is full of fibers and toilet paper and skin cells and all sorts of things, clean it all up in a non-destructive fashion, and get it to the point of that slide on the right-hand side, where we could identify quite simply the plastic particles that were there using spectroscopy. And then also we had very good reproducibility when we spiked our samples. And we've since moved into also using pyrolysis. Pyrolysis is enormously useful when you get below the 20 or even 10 micron level, where the other instruments have a hard time finding particles. When you get down into the very low micron and into the nano sizes, then pyrolysis seems to be the best way to make identifications, although you do destroy your sample in the process, so that is one of the trade-offs. So we can go to the next slide. And in terms of making progress, so beyond the international standards, which have now been adopted and approved as of 2020 for the collection and the preparation of the samples, the identification methods and the reference fabrication practices are still in the committee, and they've gone through a number of reviews, and hopefully they will come out in the next year or so. So the sort of standard setting is moving at a very good pace. The state of California is a big part of helping us with all that work. And so I think in terms of having the research and the collection part of and the analysis part of sampling done, I think that's really moving forward. EPA itself adopted the Trash Free Waters program in 2013. So they took our regional marine debris plastic pollution program. They made it a national program under trash-free waters. So the umbrella of trash-free waters is extended to all of the United States, and it is now incorporated into the Save Our Seas Act 2.0. So it is now an official program with an official funding source and official statutory authority. And EPA has also moved into designating trash as a pollutant. And as recently as 2020, they designated Kamilo Point Beach and Turn Island as impaired due to trash, so due to plastic specifically. They required the state of California to establish a not to exceed threshold for this pollutant going into the waters. And it ties back very closely to sort of the name of the company that I've co-founded with my co-founder, Bill Robertson. On your upper right here is a picture of Kamilo Point Beach. And in 2013, I was invited by the Hawaii Wildlife Fund to go out to look at this beach with them, and Bill joined me. And as we waded sort of knee deep in plastic pollution, we made a pact with each other that at some point we were going to start a company that was dedicated to bringing a solution that was sustainable and that would help all the other solutions that were out there to address the problem of plastic pollution. So we weren't sure what that looked like. We knew it needed to be something that would make plastic valuable. We knew it needed to be part of a circular economy, but we need to also figure out how to do that. But standing at that beach, we just knew in 2013 that was where we were going to be headed. And it was really interesting during COVID when we were all at home in 2020. Some of the attorneys that we worked with for many, many years called us and said, guess what? Kamilo Beach is one of the places that we've designated as impaired due to trash. So it was sort of a really nice sort of circling back to the origins of what had inspired us to start our company. So the next slide I want to show you, if you can go to the next one, is just sort of the sort of final link of plastic to climate change, because this is an issue. Plastic pollution in and of itself is a huge environmental problem for ecosystems and potentially for human health. But beyond that, it actually is very closely tied to climate change and climate action. So there's a strong likelihood that plastic pollution interferes with the carbon cycle because creatures eat the plastic rather than eating the detritus and the other things that they're supposed to be eating in the ocean, and then that interferes with the entire carbon pump and the carbon cycle. There's also a concern that the same currents and the same movements of the wind that move phytoplankton around the ocean also move the little tiny pieces of microplastic around. And so it's very likely that in the chlorophyll A fronts, which is where the phytoplankton sort of end up and reside, that those fronts are also highly polluted with microplastic, which competes with the phytoplankton for sunlight. And the sunlight is absolutely necessary for our oxygen supplies on the Earth. Phytoplankton produce more than 50% of the Earth's oxygen. And so as we fight climate change and try to get our oxygen levels up, reduce our carbon dioxides, if we decrease the amount of phytoplankton in the ocean, we're working against our own best interests. And so it's a system, you know, we're all a big system here on the planet, and we're all interconnected. And so the phytoplankton have this really huge role at the very, very, you know, basic part of our ecosystem to produce the oxygen for us. And we need to make sure that we kind of help them with the microplastic pollution part and reduce that. So with that, I'm going to go to the next slide and sort of change the gears of what I've been talking about and get into sort of moving forward rather than looking back. When I worked at EPA, I would kind of get to this point in my presentations, and that would be what I was presenting, and people would come up to me afterwards and they'd go, that was super fascinating and super depressing, and I feel just like hopeless now. And honestly, that was a terrible feeling for me to have imparted to my audiences and my people that I was sharing the information with. And so, you know, at some point in all of this, and particularly 2020 crystallized it for me, just sort of evaluating things from a somewhat different perspective. I came to the conclusion plastic is in the ocean to stay. There's really no way to get it out. I had initially started coming from my emergency response and removal program with the notion, you know, way back in 2009, let's get it out. I now know more. a lot more. And I don't believe that's possible. I think that the collateral damage of all the tiny, tiny creatures that are the same size as the microplastic would be too great. The oceans are far too large. And the depth from the top down to the very lowest part, which is 18,000 feet, just makes it engineeringly pretty much impossible. So I think that what's in there, what's already in the ocean, is there to stay. And that is a very depressing notion. It will eventually sink to the bottom of all of the water bodies. We will have a geologic layer of plastic that gets entrained and gets other things put on top of it. And it will be a little memorial to our mismanagement of plastic waste in the 20th century and the beginning of the 21st century. And I would really like that plastic layer to not get any bigger and to stop right now. And so that's really what inspires me and inspires my co-founder, Bill Robertson, to do Kamilo's work. We came up with sort of the realization that we can study microplastics and maybe even go into nanoplastics and study them and the risks and the threats that they pose all day long. And at the end of that, understanding it better does not stop the problem, does not bring value to plastic, it does not stop the source of the plastic pollution. So what we needed to do was come up with a way that could make recycling something that was so great that it would be inconceivable to not do it. And recycling is really one of those things that is not really thought about enough, in my opinion. And it has such a huge link to climate action. 1 pound of recycled feedstock produces 1 pound approximately of greenhouse gases. A virgin pound of virgin plastic produces 3 pounds of greenhouse gases. It's very easy to see that using recycled plastic in a new product, whenever possible, saves an enormous amount of greenhouse gas emissions. And so the recyclers in our world are our action climate heroes, in part because they do a lot to help with climate action. And so Kamilo was established to try to uplift the value of plastic, provide the missing data. There's really very little data in understanding post-point of sale, what happens to plastic? Does it really get recycled? If a plastic product says it has recycled content, does it really have recycled content? So we wanted to come up with a way to track the plastic from the point of collection to the point of use in a new product and be able to show through our chain of custody and our proof of provenance where it came from and where it ended up. And so there's still a missing gap, which we will deal with over the years as we get more and more data and more aggregation. And that is what happens from the point of sale to the point of collection. That gap still exists. And as far as I know, there's really no way to fill it just yet. But I do believe that we will be able to do that in the years to come. And so let's go to the next slide now. And I just want to acknowledge that there are many solutions and there are many resolutions that are being put forward to combat the crisis of plastic pollution. And many of them are very hopeful and very likely to work, some in the more immediate term and some over the longer term. And it really is a case of every little bit helps. So no matter even if it's at the individual level or it's a small company or a large company, all of these things help. But I think that there are two critical solutions that need to happen in the near term that will enable the success and the effectiveness of all of these other solutions to be measured and to move forward. And this is my opinion based on the sort of decade plus experiences that I've had working in the realm of plastic pollution. So we'll go to the next slide. And what this is, of course, is harkening back to all the experiences I've had with ASTM, which have been very positive and I think have a huge role in the future of plastic. One of the most confounding things about recycling is that the plastic itself there's many different polymer types. The polymer types are combined together, and then there are thousands of chemicals that are added into that plastic. All of that makes it extraordinarily challenging to recycle plastic. Makes it challenging for the consumer to know which things are recyclable, which aren't. Makes it challenging for the recyclers to know which ones they can use in what products. And so I think that standardizing much of what we produce in plastic is an absolutely essential next step. So source reduction, don't use plastic in things that don't need to have it, is an obvious first step. One of the things that it just is very infuriating for me when I'm purchasing products is if I say I buy a bottle of shampoo, it's in a plastic bottle, it's got a plastic sort of little locking mechanism, then it's put into a cardboard box, which then has a plastic shiny wrap on it. And I feel like, I'm going crazy. I have to take off this unnecessary plastic shiny wrap. I have to waste the cardboard box, which was not necessary, just to get down to the product that I'm using. So I feel like there's many, many instances where we could scale back enormously, and brands could just take a step back from sort of the vanity of needing their product to look as beautiful as possible, and have the consumers just say, yes, this is good enough. I know what I'm buying. I can live with this in the name of helping the environment, and just really simplify what they're buying. I don't think colorants are necessary for the most part. I think they're a vanity. If you're buying laundry detergent, you don't need it to be a brilliant orange color to tell you this is laundry detergent. It's just unnecessary. And that orange color makes that plastic almost impossible to recycle, except into a very few products. And so you can simplify the amount of additives that are used. You can simplify the number of polymers that are used in combination, and you can simplify the recycling sector enormously through an agreement on standardization here. It works across all other industries. Construction industry is one, automotive is another. There's so many industries that are standardized, and I think it's time that the plastic industry do that too. And then let's go to the next issue, which is really sort of, to me, the sort of crux of what Kamilo brings to the table. So this is the notion that measurement and proof are a necessary component of circularity and of supplies and supply chains and waste supply chains. And so Closed Loop Partners is one of the big organizations in the space of the circular economy. And in October of last year, they came out with a report. And in the report, it was talking about the need for accountability and traceability in the supply chain. And they said it's long overdue for a digital transformation, because up until now, everything is a paperwork exercise. They're still in the 20th century on that part, the recycling and the waste supply chains. And there is a need for transparency and traceability. And this dovetails very, very nicely with what Bill and I have come up with for Kamilo, which is to develop a technology that can track from the time that something is collected all the way into its next product, and provide proof of origin, proof of processing, proof of recycling. And it gives data on the movement of that plastic in the waste supply chain. So we'll go to the next slide now. So the way that the business is set up is it's set up to do a certification of any facility to make sure it has sound environmental practices coming from the EPA. We did a number of inspections of many facilities, and we know that we don't want to work with a facility that is already hurting the environment in other ways. So that is a basic threshold to work with us. And then we work with, it's a very, very simple process on the front end. We attach an identification, digital identification code to an item. So I just want to be clear, this is not a bottle. It's not at that granular of a level. It's a bale or a gaylord or a super sack or a truckload. So anything that's an item that can sort of be compartmentalized. And that's much more granular than anything that exists today, which is generally done just sort of a self-certification type of process at this point. But it's a very granular, and we track it from the point of collection. So we track it by polymer type and by weight, and we track it into the processing, broker to processing, and from processing into manufacturing, and from manufacturing into the product. And we can do full circularity. We can track that product back to the brand that buys it, and so demonstrate this full circularity. And we believe that by doing this, we can show that the recycled content in a product has absolute ironclad proof of where it came from and how it got there and how much is in it. We can also show the greenhouse gases that were avoided through use of that recycled content. And we can show how much landfill space was saved by not sending it to the landfill. So there's all these environmental metrics that are associated with doing something that's the right thing to do anyway. And then we can go to the next slide. And we have a vast amount of potential beneficiaries from this technology. The municipalities who hire the haulers, the processors and the haulers themselves, the manufacturers, all of those can confirm that their plastic waste was collected and it was recycled, and they can quantify the climate benefits. And then the companies that use the recycled plastic in their products stand to benefit by showing that they have verified recycled content in their products. And we're actually working on a way to give some sort of little peelable sticker or something on a product that can give like a QR code where you can scan it and see the origin of where it came from and the amount that went into that product. So there's this underlying need for data, a need for accountability. There is so much more demand for recycled plastic than there is availability of recycled feedstock. So when you have a huge demand and a low supply, it tends to create an atmosphere or an environment of, perhaps exaggerated claims and even perhaps fraud. And so having this verifiable data set is going to be a significant improvement and help for the players who are really using recycled content in their products. And so we can go to the next slide. And I just want to say thank you so much for being able to share my sort of history of my plastic pollution passion and wanting to help with the problem. And I would love to take questions and answer them, hopefully, if you can.
Thank you very much, Anna Marie. I am going to now take a look at the chat section. I don't see any questions there yet. If any, oh, I see one question from Lisa. Um, Lisa is saying, I didn't know that plastic attract and concentrate other contaminants and study about plasticizers found in lanternfish. Never thought about the creation of a geologic layer of plastic. Thank you for the information session and best wishes to Kamilo. And I share that same message. I also didn't know. Uh, you know, that plastic is kind of like absorbing all the other legacy pollutants in the environment. So thank you for that. And okay, Paul has a question. Paul, I think you're on mute. Please go ahead.
Oh, I don't think.
Oh,
Am I on mute?
no, no, you are
I
not.
sh-
You're not. We can hear
oh,
you.
okay. That's great presentation. I am with the company CR&R. It's one of the larger recyclers in California. And in my previous incarnation, I oversaw recycling in California. So, in the government sphere, we had very difficult time working with the plastics industry on solutions. There's perhaps some of the type that you're suggesting here. And plastics are particularly difficult for companies like ours. They're very light, cost a lot of money to handle. And you mentioned there's a shortage of available material against a large demand, but I'm not really familiar with that correlation. We always are fighting to get to markets. They're not fighting to get to us. So, what are your thoughts? I know that was a somewhat disjointed um, statement, but I just don't know how to solve the supply demand. The prices are typically very low, high cost to collect, and that's a conundrum for managing plastics.
Yes, you put a lot into your comment there, and I think that a lot of that those are things that we've found over the course of our work, and especially over the course of starting Kamilo. And so the business model that we are working with is designed to try to feed money back into the recycling waste supply chain. So we recognize that recyclers, the haulers, the processors, they do not have enough support, both from an infrastructure standpoint and just a resource standpoint in general, to do the work that they need to do. The shortage comes from this, there's actually a few different things that are causing the shortage. One of them is, like the California, for instance, is putting recycled content mandates in place, like sort of minimum recycled content for beverages, for beverage containers, for plastic bags, things like that. So that's coming online. And other countries are also doing that. So I think that's going to be increasing, and the brands and the CPG companies can see this, right? There's also a lot of commitments that have been made by brands and by corporations for using recycled content in their products, or simply, like say in the case of Coca-Cola, recycling 1 bottle for every bottle they produce. There is literally no way the infrastructure can handle capturing and recycling 1 billion bottles a day. Coke produces 2 billion servings a day, or 2 billion bottles. There's no way they can keep up with that. So there's a huge need, in order to make those claims valid, there's a huge need for an increase in capacity for recycling and a support for the recycling industry. In Mexico, it's interesting. They have a sort of a different way of setting up their recycling structure, but their PET recyclers there are booked out for their supply like years in advance. They're already they've got the orders years in advance, so they need more capacity immediately. And I think that the US is starting to see that happening here too, that there's not enough supply. And there's a huge amount of work that needs to be done on like quality of recycled plastic, because food grade versus grade for, say, durable goods and other things like that is vastly different. And there's going to be a need for virgin still for food grade applications, medical applications, things that, you know, can't have any sort of contamination present. But I think there's many, many applications that can use recycled content without it needing to be food grade. And the more we can kind of streamline what goes into that on the front end as the feedstock, the easier it's going to be to recycle on the back end. So our hope is that, you know, through better data, through better accountability, through better management, through more transparency and traceability, that the whole system sort of gets lifted up, the value of plastic gets raised. And yes, it does cost more than virgin plastic, but there's hope that that might change too. And I think, you know, we're trending towards having much more support for the recycling industry. I think that's my sense of it. So I hope that your experiences in the past, which are, you know, exactly what we've been hearing about, I hope that there's a different world out there as we move forward in the next few decades.
Thank you.
Thank you, Paul, for the question, and Anne-Marie for the answer. We have a few more questions in the chat section. Andrea is saying, we know that there are environmental impacts, but I want to ask, what are the health impacts of plastics in the environment?
It's an incredibly challenging question to address. And one of the reasons that I kind of ended up getting very frustrated with the research part of it, there's so many different confounding factors that go into trying to tease out what is due to a plastic and what is due to a contaminant on and in a plastic that may be present in the environment anyway. So let's take, for instance, PFAS. PFAS can be in many, many different, it can be in plastic, it can be just in the water. So if you see PFAS in a body, polyfluorinated, I can't even remember what it stands for. Sorry, that's a bad example to use when I can't remember. It's a complicated acronym, but it can have an impact on the body, and yet you don't know, is it due from the plastic or is it due from the other things in the environment that carry that contaminant? Our world has a lot of legacy contaminants, a lot of new contaminants in all the different environmental media. And so trying to know, is it from a plastic, especially from a particle that may be too small to even find and identify if it's in a nano size, if we're breathing it. So if we walk across the carpet and we release little plastic microfibers and microparticles from the sort of synthetic carpet that is in many office spaces, we breathe that in. What is due to just particulates from wildfire smoke getting into our lungs? What is due to the carpet? How do you tease out? How do you know? So there's lots of chemicals that we know individually are affecting human health. And there's a very sobering book called, I believe it's Countdown, that talks about the impacts of endocrine disruptors, and plastics play a part in that. on the human reproducing system, the ability to reproduce, especially for males. And, there is definitely concern. It's definitely alarming. Understanding it may be helpful. I think what really needs to happen, though, is an acknowledgement that if we use plastic, we need to take care of it. We need to put it into a new product. We need to use it again. We can't let it get into the environment. And so that, I think, is really at the end of the day, that's what we need to take home. So I think that there's definitely a risk associated with plastic. Quantifying that risk is extremely challenging, and taking care of it at the source, reducing the amount of plastic used, and taking care of the plastic that we do need to use, that's really where the solutions lie.
Thank you. And I want to add that Andrea also added a message saying, by the way, I loved your presentation. You're doing great work, very admirable, and it inspires to keep trying to look for solutions.
Thank you, Andrea.
So also, Donald has a question. The message is, I viewed the House Select Committee hearing this morning on oceans. Plastic came up, and one representative was positive the US is not the worst plastic polluter. Any way to tell where the plastic originates?
Again, a very, very tough question. So I would say there's different ways to look at it. The way I look at it is that the US is the largest consumer of plastic products. We have, per person, we use more plastic than any other nation on earth. Doesn't mean we have the most plastic because we don't have the most people, but we use the most per person. So our consumption habits are that we use the most plastic. The US historically used to ship our plastic overseas, and we would go, okay, we've taken care of it, and nobody knew what happened to it. And, until China put in place its national sword policy, closed its doors, said we're not taking any more plastic from other countries, the US didn't really have to worry about it. Now they have to worry about it, and they ship it to Canada and Mexico, and Canada and Mexico ship it overseas to Turkey, to Vietnam, to other places, but not nearly as much as they used to. And so we are, because we're not shipping out as much and exporting as much of our waste, we are sort of acknowledging, gosh, this is a really huge problem in the US. So the US likes to think that we lead the way along with Western Europe in recycling and management of our waste. And in many respects, we do. We have extremely good wastewater and drinking water standards. So there are a lot of things that are really, at the top of the class and sort of set the standard. However, about half of the US does not have access to curbside recycling and to a recycling drop-off place. And so 50% of what we buy does not have a destination other than a landfill. So that's not a great use of our resources, and it's not a great waste management strategy. Other countries don't even have access to any sort of infrastructure. And so, how do you balance a country that has the ability to put infrastructure in place and doesn't, with a country that doesn't have the resources to do that? I don't know, how you weigh that. And so I feel like it is incumbent on the US to get its own house and its own home in order here within the US. And we've done our work initially with Kamilo in California and the US to kind of prove that point. And I think then we can trade, we can show the lessons learned, we can help other countries. And it's a global problem. I think those 5 gyres sort of speak volumes, right? We're all connected. One nation's waste becomes another nation's waste. So we do all need to own this. And the US is in no way blameless on this one.
Thank you. Also, Susie has a message here saying, until just now, I have been using my activist voice to educate communities to stop using plastic. However, now I'm going to be changing gear to campaign for plastic production regulations, seeing as though so much plastic is produced overseas, unless global governments agree, will remain in the same polluting situation. How do we enforce this globally?
Yes, that's a huge question, Susie. I think, there's certainly been movement over the last decade for sure at the sort of level of the United Nations in terms of and the United Nations Environmental Program in terms of bringing plastic awareness and plastic strategies to the forefront for multiple nations. And then there's the Basel Amendment, which has sort of tried to regulate how exports work. The US didn't sign on to that. So, that's really troublesome when we have a global agreement that the US won't sign up for. So we do have all these impediments to making things work on a global basis. I think really at the end of the day, giving plastic value is the key to having it be treated better. For instance, aluminum cans, and there's some environmental aspects of aluminum that really, that have their own problems that should be solved. But aluminum is valued. Aluminum cans are recycled over and over and over. And the fact that glass used to be and isn't is an incredibly sad point for me and for my co-founder, Bill, because there's a shortage of glass. There's a shortage of sand to make that glass, and it needs to be valued too. So this happens to different types of resources, but the circular economy that people are talking about so much, that is prevalent throughout all these publications, the circular economy is predicated on valuing resources that are produced. So going back to your production, Susie, so produced, valued, and put back into reuse. And so that's what really I think is the key to solving this, is that plastic has to be something that we value so much that we go and mine out of our landfills, out of our dumps, and reuse again. So hopefully that's where we will get to.
Okay. Thank you. And we have one last question. I kind of will summarize it in the interest of time. Esmeralda is asking, is expressing interest and appreciation for the work you're doing, and asking if there is any way they can get involved regarding internships, employment, or volunteering with your company.
Oh, I love to hear that. Thank you so much. It's wonderful. We're very small still, and we hope that in the rest of 2022, going into 23, that we have the ability to expand rapidly, and we will be looking for interested applicants to help us along our journey. So please stay in touch, stay tuned, and yes, hopefully we will become a recognizable entity in a year. Household name within 5 would be lovely. And yeah, hopefully we will help be a real instigator in changing the views of plastic around the world and the way it's treated. And the resulting environmental impact will hopefully be mitigated and minimized extensively.
Awesome. Great. Thank you very much, Anne-Marie, for taking the time to talk about such an important topic.